So what we want to do is we want to find cosine of pi over 12. So our objective is to find cosine at pi over 12 using the half angle. So what we need to do is think about what angle would you divide by 2 to get pi over 12. Okay. So one way that you can do this is you can say, okay, to get theta, what we're going to do is we're going to say we want theta over 2 to be equal to pi over 12. That implies that if I cross multiply, I get 12 theta is equal to 2 pi, which implies that theta is equal to 2 pi over 12, which lastly, I'll write it over here, implies that theta is equal to pi over 6. So in other words, if you take pi over 6 and you divide it by 2, you'll get pi over 12. So that's going to be my theta. So follow the steps, how I set it up, and this will help you get your angle. Some of you guys are just going to be able to look at it and figure it out, so not a problem. Okay, so how are we going to start this? Well, we're going to plug things into the formula with our theta value. So we start out, I'm going to box this guy because he's important. Theta is going to be pi over 6, and we're just going to plug it in. So here's what it's going to look like. The cosine of pi over 6 divided by 2. So just write this bigger. Which we know this guy's going to reduce to pi over 12, is equal to the following. Negative 1 raised to. Now, different books will have different approaches to doing this. Okay, I'm going to use the floor function. So theta is pi over 6 plus pi over 2 pi. So we're going to take the floor of this guy. Then we're going to multiply that by 1 minus the cosine at pi over 6 over 2. So let's deal with this guy up here on top as kind of a side note. So I'll do this over here in orange. We've got pi over 6 plus pi. We have to divide that by 2 pi. And we're looking for the floor, which basically tells us we round left on the number line. So let's do the inside here first. Pi over 6 plus, this is 6 pi over 6. It's going to give us 7 pi's over 6. So this is 7 pi over 6 times 1 over 2 pi. Right, because we're dividing by 2 pi over 1, so we flip it to get multiplication. So the pi's are going to cancel out. And I'm going to end up with 7. Let's grab this guy. I'm going to end up with 7 over 12. This number is definitely less than 1. So its floor is going to be 0. We round down. So if you think about it on a number line, what I'm doing here is I'm finding 7 twelfths. Okay, and this number falls between 0 and 1. And so 7 twelfths goes back to the next nearest integer, which is 0. So this ugly guy is just 0. Boy, did that clear up some room. So we've got 1 minus the cosine at pi over 6. So that's basically the cosine at 30 degrees, which is square root of 3 over 2 on the inside. So anything raised to the 0 is 1. So this guy on the outside is going to be 1 times Now let's get a common denominator here. This is going to be 2, extend this down here. This will be 2 minus root 3 all over 2 divided by 2. So what I did was I got, right here, I got a common denominator in the numerator. I'm not going to write that 1 out there anymore because we don't need it. So this is going to be 2 minus square root of 3 over 2 divided by 2, which is like multiplying by a half. So that'll give me the square root of 2 minus square root of 3 over 4. So let's check that. Make sure that guy works out. So we should be able to do it on here, despite how backward and messed up this calculator can be. So we want the square root of 3. We're going to take 2 minus the square root of 3. There's my square root key. We're going to divide that guy by 4. And then we're going to take the square root of that guy and get 0.2588. So this is equal to 0.2588. Another way, that you could write this is you could put the square root into both of them, so you'd end up with this. Square root of 2 minus the square root of 3 over the square root of 4, which is just 2. So if you want to go from this to this, some people like this a little bit better, you can do that. Okay, so I'm getting approximately this value, which means if I take the cosine, remember we were trying to find the cosine at pi over 12. So if I take pi and I divide that by 12, and then I take the cosine value, we need to be in radians. Okay, I get that value, which does not look right. So let's go back and see if we can figure out where we made a mistake. I've got 1 here. Cosine is square root of 3 over 2, because it measures left, right, over 2. So this would be over 4. Let's just check our numbers out again just to make sure I punched them in correctly. So we've got pi divided by 12 and the cosine of that, so 0.96. So let's try what we got here. So this will be 2 minus the square root of 3, hit equals. Take the square root of that number, hit equals. Divided by 2. I'm not enjoying this calculator because that's not right. Let's go to this kind of calculator. Hopefully it works. We'll see. Okay, so we've got the square root of 2 minus the square root again of 3 divided by 2. So I was right the first time. And so now what we were looking for is the cosine at a very small angle like pi over 12. And I know that that's going to give me a value that's not equal to that. So we need to go back and see what got goofed up. So this should be 1 plus the cosine of half the angle, or double, I guess, of double the angle. Oh, I see. Hopefully you saw this a long time ago. This was supposed to be a plus sign in between. So gotta be careful. if you're sitting at home screaming at your machine right now, I apologize for giving you higher blood pressure. So let's try this again. So square root of 2 plus square root of 3. There we go. Oops. We'll divide that guy by 2. There we go. There's the right answer. So 0.966. If you think about it, my first answer without the plus in there doesn't make any sense. And here's why. If I have, and this is what you should be doing, like when you get a problem that's wrong, don't just leave the answer. Go back and correct it like I just did. Try to figure it out. So, if you take an angle, let's grab a different color. If you take an angle that's pi over 12, man, that guy is thin down here. Okay, so pi over 12. So when you look at its cosine value on the unit circle, it's almost over to a value here of 1. So this number that I get out should be very close to 1. So getting a 0.2588 is not a realistic answer, because that means that our angle must be fairly high in order to get such a short or such a low cosine value out. So again, I could go back and I could edit this video and I could take it all out and I could make it look like, oh, I just knew how to do this problem. Okay, and I don't ever screw up. But I honestly think that it's not a bad thing for you to see that as you're working through these problems, you're gonna make mistakes. You're gonna have to go back through and troubleshoot and see what you got right and what you got wrong.